For this rational equation, we are going to start by finding the LCD. And before we can find the LCD, I need to make sure all of the denominators are factored. X minus 5 can't be factored, but x squared minus 25 is a difference of squares, and this factors as x plus 5 times x minus 5. It's very important to make sure all denominators are factored before finding the LCD. Otherwise, you're likely to not recognize common factors and end up with an LCD that is too big. While it still may clear the denominators, you'll end up with a higher degree polynomial equation to try to solve after the fact. So, my last denominator is just an x. My LCD has to have all of these factors in it, so it needs a factor of x plus 5, a factor of x minus 5, but we do not need two copies of this factor x minus 5. It shows up twice, but it shows up twice in two separate denominators, so we should be fine with the version that we have. I am now going to multiply this LCD by both sides of the equation. So I'm going to write down x times x plus 5 times x minus 5 and multiply this by the left side of the equation. So in brackets now I will put 2 over x minus 5 minus 20 over x plus 5 x minus 5 equals, on the right hand side I have 3 over x and then another copy of my LCD. So I'm ready to distribute this whole LCD into the left hand side of the equation, and on the right hand side I really only have one term to multiply it by, so I can just multiply. On the right-hand side, it's a little simpler because of the one term. I can actually do this cancellation in pen, and I can see that what I have remaining is 3 in the numerator, and then x plus 5 and x minus 5 from the LCD. We'll write that down after we have done the left-hand side. Looking at the left-hand side, I can see that from my first product, these x minus 5s would cancel out, leaving me 2 from the numerator and x times x plus 5 from the LCD, but I don't want to actually do that cancellation in pen because that might create a little bit of confusion for the next product. So I'm going to just visualize that and write this as 2. Seeing that the x minus 5 factors would drop out, I will then have remaining x times x plus 5 from my LCD. For my next product, I have the numerator 20. X plus 5 and x minus 5 this time are the factors that drop out. So again, I can temporarily cross those out or cover them up with a finger, and I can see that the factor x is all that remains in this case. So I'm going to write that term as minus 20 times x. And now, as we said previously, on the right-hand side of this equation, I have 3 from the numerator, and I have x plus 5, x minus 5 from my LCD. So the clearing fractions, or the clearing denominators step, is really just a process of getting rid of all the denominators and seeing what we have remaining. We're going to need to multiply this out before we really know for sure what kind of equation this is. Sometimes these turn out to be linear, and this we would multiply out using FOIL. Sometimes these turn out to be linear, sometimes they turn out to be polynomial. In this case, because this is a product of two conjugates, x plus 5 times x minus 5, this is like a difference of squares pattern. I know that the outer and inner terms are going to drop out, so I am not going to calculate them. Just the f and the l are the only terms that will remain. So I have now 2x squared plus 10x minus 20x equals 3 times, my first and last are just x squared and minus 25. There would be no real harm in calculating the entire FOIL, but we would find that the outer and inner terms drop out, and when our problems start to get longer like this one is, those little efficiencies start to add up to a bit more. Just cleaning up a little bit here, I combine the plus 10x and minus 20x on the left-hand side to get 2x squared minus 10x. And on the right-hand side, I will distribute into the parentheses to get 3x squared minus 75. At this stage, it looks likely that I have a polynomial equation. So because this is a polynomial equation, I'm going to solve by factoring. So because I'm solving this by factoring, my next step will be to move all the terms to one side. I'm going to choose to move these to the right because that's where I will get a positive x squared term. And this negative 10x doesn't have any terms to combine with, so in this case I prefer to think of it as just moving it across the equal sign and changing its sign. So in the next step I will lose this 2x squared. I will move the negative 10x so that this becomes x squared plus 10x. Always change the sign as we move the term across the equal sign to the other side. We would move it by adding 10x to both sides. And then minus 75. This is a fairly straightforward factoring problem because it starts with an x squared. I know that both factors need to start with x. I can see that 15 and 5 are the numbers that would work here, where we have plus 15 and minus 5 in order to get us negative 75 as a product and positive 10 as a sum of the outer and inner. So the first factor gives me, when I set it equal to 0, x equals negative 15. And the second factor, when I set it equal to 0, gives me x equals positive 5. Now I do need to check to make sure that both of these are in the domain. So I'm going to go back to the original equation and see what my domain is. And often it's helpful to just go straight to the LCD. The LCD is a brief little summary of all of the factors that show up in a denominator. So from the LCD we can get the domain. We just want to make sure that none of the factors in the LCD are equal to 0. So because x is a factor in the LCD, that means x cannot be 0. Because x plus 5 is a factor, that means that x cannot be negative 5. And because x minus 5 is a factor in a denominator, that means that x cannot be positive 5. So these are the three values that are outside of my domain: 0, negative 5, and positive 5. Looking back at my solutions now, I want to just check to see if they are both in the domain, and I can see that positive 5 is one of the numbers I said x cannot equal, so we have to throw this solution out. It's not in the domain. And so as it turns out, x equals 15 is really the only solution that we are going to keep. We can call that x equals 15 as our solution, or we could write this as a solution set, or negative 15 rather. The set containing just the value negative 15. If we had only one solution and we had to throw it out, then at this stage we would just have to say no solution.